Ever wondered what everything around you is made of? It all comes down to chemistry, the study of matter and its interactions. Matter, in essence, is anything that occupies space and has mass. It's composed of atoms, the basic building blocks of elements. Think of elements as unique, unbreakable substances. They can't be simplified further. You've probably seen the periodic table, a scientific chart that organizes these elements based on their atomic number. That's the number of protons in an atom. Elements in the same column? They share similar chemical properties. So what's inside these atoms? Atoms consist of protons, which carry a positive charge, neutrons with no charge, and electrons negatively charged. Central to the atom is the nucleus, home to protons and neutrons, while shells of electrons surround it. It's the arrangement of these electrons that determines an element's chemical behavior. And how do atoms stick together? That's where chemical bonds come in. Covalent bonds involve atoms sharing electrons, while ionic bonds involve the transfer of electrons. These interactions give birth to molecules and compounds. Matter can exist in different states: solid, liquid, gas, and plasma. It's temperature and pressure that can transition substances between these states. Now, chemical reactions are all about transformation. They involve the conversion of substances, known as reactants, into new products. Chemical equations are the shorthand for these transformations. Ever heard of acids and bases? Acids release protons, or H+, in water, while bases accept them. The pH scale is a measure of a substance's acidity or alkalinity, with acid-base reactions playing a crucial role in many chemical processes. Chemical kinetics is another fascinating area. It's all about the speed of chemical reactions. Factors such as concentration, temperature, and catalysts can influence how fast reactions occur. Thermodynamics explores the energy changes in chemical processes. Enthalpy, entropy, and Gibbs free energy are key concepts here. If Gibbs free energy is negative, reactions occur spontaneously. Organic chemistry zeroes in on carbon compounds. Hydrocarbons, made up of carbon and hydrogen, form the basis of organic molecules. What's more, functional groups can impart specific properties to these compounds. Biochemistry examines the chemical processes within living organisms. It's all about key biomolecules like proteins, nucleic acids, lipids, and carbohydrates. Nuclear chemistry, on the other hand, studies processes involving atomic nuclei, such as radioactive decay and nuclear reactions. It's a field with applications in medicine and energy production. Analytical chemistry is about analyzing and identifying substances. Techniques like spectroscopy, chromatography, and titration are commonly used. Finally, environmental chemistry studies the impact of human activities on the environment. Topics include pollution, climate change, and sustainable practices. So, there you have it. Chemistry, a dynamic field with broad applications. Understanding its fundamental concepts provides a basis for comprehending the natural world and developing solutions to real-world challenges. It's the science that's truly all around us.